This is the Messerschmitt Bf-109, the silhouette that defined the Luftwaffe's fighter arm in World War II. More than a famous aircraft, it became the backbone of Germany's air war and one of the most lethal fighters ever flown. In this film, we're focusing on the most widely produced branch of the 109 family, the Gustav, and specifically the G6, a variant built in staggering numbers, with over 12,000 produced. When the G6 entered frontline service in early 1943, it wasn't an unstoppable superfighter compared to its latest opponents, but it was rugged, adaptable, and practical. A design that could be pushed into almost any mission Germany still needed. Interception, escort, fighter bomber work, and defensive scrambles. That flexibility is exactly why the G6 appeared across every major theater where the Luftwaffe fought. From brutal eastern skies to the desperate defense of the Reich. My name is Marcus Reed, and this is Iron Blueprint. The Bf-109 G6 was built around a straightforward but highly efficient airframe philosophy. It used an all-metal construction, centered on a single spar wing design, with fabric-covered control surfaces to reduce weight where possible. From the beginning, German engineers prioritized two things above all else: lightness and ease of maintenance under frontline conditions. The structure relied heavily on riveted aluminum panels. On external surfaces, flush countersunk rivets were used to reduce aerodynamic drag. A small detail, but one that mattered at high speeds and altitude. In terms of size, the aircraft was compact even by fighter standards. The fuselage measured just over 22 feet in length, and the aircraft stood roughly 8.5 feet tall when resting on its landing gear. The wingspan stretched to just under 33 feet. This compact footprint translated directly into performance. The G6 had an empty weight slightly above 6,000 pounds, and when fully loaded for combat, it weighed approximately 7,700 pounds. Every pound saved improved climb rate, acceleration, and maneuverability, qualities that remained critical even as Allied aircraft grew larger, heavier, and more powerful. The result was an airframe that, while increasingly stressed by later war demands, still delivered a strong balance between strength, performance, and operational practicality. The fuselage of the Bf-109 G6 was divided into a series of distinct structural sections, each designed to serve a specific mechanical or operational role. In total, the fuselage consisted of 10 main sections arranged along a central structural axis. At the very front sat the engine section, which housed the DB605 engine, along with the aircraft's forward-mounted weapons. Immediately behind it was the cockpit section. Beneath the cockpit floor ran the central fuselage beam, a critical structural element to which the wing spars were directly attached. Behind the cockpit, the third fuselage section contained the main fuel tank. This tank had a distinctive L-shaped design, allowing it to fit tightly within the fuselage while maintaining the aircraft's compact profile. Further aft, the fuselage sections accommodated essential systems such as radio equipment, control linkages, and at the rear, the tailwheel shock strut. These components were carefully arranged to preserve balance while keeping maintenance access as simple as possible. One of the most distinctive features of the Bf-109's fuselage was the way these sections were manufactured and assembled. Each fuselage section was built from two symmetrical halves. These half shells were joined together using horizontal rows of rivets along the top and bottom. To connect one section to the next, the edges of each half were bent inward, forming flanges that allowed the sections to interlock. Once aligned, the sections were secured using a single vertical row of rivets, creating a strong but lightweight connection. Longitudinal stringers were then passed through openings in the internal frames, reinforcing the structure along the length of the fuselage. This construction method resulted in a fuselage that was both rigid and lightweight, an essential balance for a fighter aircraft expected to climb rapidly, maneuver aggressively, and survive repeated combat sorties. For a fighter as compact as the Bf-109, the G6 was comparatively well protected. German engineers concentrated armor where it mattered most, the the pilot's head and upper torso, and the areas most likely to be struck during head-on attacks or defensive fire from bombers. At the front of the cockpit, the windshield and the rear section of the opening canopy were reinforced with thick, laminated armored glass. This armor glass was built to resist fragments and small caliber fire while still preserving forward visibility, which was critical during high-speed intercepts. Behind the pilot's seat, the aircraft carried a solid armor plate designed to stop or weaken rounds that penetrated the cockpit from the rear. This rear armor protected the pilot's spine and vital organs during tail attacks, one of the most common threats in fighter combat. Additional protection was placed behind the fuel tank. Here, layered duralumin armor formed a barrier intended to reduce the chance that a hit would immediately ignite fuel vapor or catastrophically rupture the tank. Early production G6 aircraft also featured a steel head armor plate behind the pilot, mounted high in the cockpit area. This gave direct protection against fire from above and behind, but it also reduced rear visibility, which was already limited in the Bf-109 cockpit. To address that weakness, later models introduced what became known as gallant armor. Instead of a solid metal plate, the protection behind the pilot's head was replaced with an armored glass panel. This preserved much of the protective value, while improving the pilot's ability to check the rear quarter, an important advantage in dogfights and disengagement. Overall, the armor layout of the Bf-109 G6 reflected a constant trade-off. The aircraft needed enough protection to keep the pilot alive, but every pound of armor reduced climb rate, acceleration, and turning performance. The G6 armor solution aimed to protect the pilot without sacrificing the light and aggressive handling that defined the Bf-109 design. The tail section of the Bf-109 G6 was built as a separate modular unit and attached to the rear fuselage with bolt connections. This design simplified repairs and allowed damaged tail assemblies to be replaced quickly under field conditions. Most G6 aircraft featured an all-metal tail structure with fabric-covered control surfaces, keeping weight low while maintaining adequate control authority. Unlike many contemporary fighters, the Bf-109 had no adjustable trim tabs for roll or yaw. The only trim available to the pilot was elevator trim, controlled by a trim wheel on the left side of the cockpit. Rather than trimming the elevator directly, this wheel altered the angle of the entire horizontal stabilizer. This system was especially important during high-speed flight and steep dives, where control forces increased sharply. Proper trim allowed the pilot to maintain stability without excessive control input, particularly during combat maneuvers and recovery from dives. The Bf-109 G6 used a single-spar wing design, optimized for lightweight and structural simplicity. Both wings were bolted directly to the fuselage, allowing relatively quick installation or removal without disturbing the landing gear. Even with the wings removed, the fuselage remained supported by its undercarriage, a feature that greatly simplified field maintenance and transport. Coolant radiators were mounted beneath each wing near the wing roots. These radiators were fitted with hydraulically operated metal flaps, automatically regulated by a thermostat during flight. During landing, radiator control was switched to manual and fully opened. This increased drag and improved the effectiveness of the landing flaps. However, the cooling system was one of the Bf-109's major weaknesses. Even minor damage to the radiators could lead to rapid coolant loss and engine seizure, often forcing pilots to disengage immediately. A distinctive feature of the Bf-109 wing was its automatic leading-edge slats. As airspeed decreased or G-load increased, negative pressure pulled the slats open automatically. This improved low-speed handling and delayed stall onset, especially in tight turns. However, the slats were not synchronized, meaning they could deploy asymmetrically, sometimes disturbing aim during dogfights. In bomber interception missions, Bf-109 G6 pilots typically climb to altitudes around 26,000 feet before engaging the enemy. The aircraft's strong climb performance allowed it to reach this altitude in roughly 10 minutes. During the climb, pilots activated the onboard oxygen system and prepared the aircraft for combat. The Bf-109 rarely operated alone. Fighters approached the target area in small formations, usually pairs or groups of 4. As the formation closed in, weapons systems were armed, and pilots positioned themselves for a single, high-speed attack pass. Against heavy bomber formations, timing was critical. The Bf-109 was designed to strike quickly, inflict damage, and disengage before escort fighters could respond. This hit-and-run approach defined much of the Bf-109's combat doctrine, especially as Allied fighter cover grew stronger later in the war. The standard armament of the Bf-109 G6 was built around a powerful centerline cannon and 2 heavy machine guns. At the heart of the system was a single 20mm MG-151 cannon, mounted between the engine's cylinder banks and firing through the hollow propeller shaft. This configuration allowed accurate, vibration-free fire directly along the aircraft's centerline. Supporting the cannon were 2 13mm MG-131 machine guns, mounted above the engine and synchronized to fire through the propeller arc. These machine guns created the distinctive bulges on the cowling that gave the G6 its nickname, Die Bowl. Each MG-131 carried 300 rounds, while the MG-151 cannon was supplied with 200 rounds of ammunition. The machine guns fired at roughly 900 rounds per minute, while the cannon operated at about 700 rounds per minute. Although the total firing time was limited to seconds of continuous fire, the concentration of heavy-caliber weapons made the Bf-109 G6 highly effective against both bombers and fighters. All weapons were electrically charged, and visual indicators in the cockpit confirmed when the guns were ready to fire. Gun convergence could be adjusted on the ground, allowing pilots to tailor their fire pattern to personal combat preferences. In addition to its internal weapons, the G6 could carry external stores beneath the fuselage, either a drop tank to extend range or bombs for ground attack missions, though at a noticeable cost to flight performance. Bf-109 G6 pilots rarely fought alone. German fighter units typically attacked in pairs or small flights of 4 aircraft, allowing flexibility and mutual support. The formation leader maneuvered to gain a positional advantage before committing to the attack. Once aligned, the group would dive aggressively toward the bomber formation, choosing targets quickly and opening fire at close range. The G6 used the KG-13A control stick, which separated weapon controls for precision firing. Before engaging, the pilot pushed a safety switch forward, exposing the cannon trigger. The 20mm cannon was fired with the thumb, while the machine guns were fired using the index finger. This setup allowed pilots to choose between short, controlled bursts or full combined firepower in a single pass. Against bomber formations with fighter escort, the Bf-109 seconds usually had time for only 1 attack run. After firing, the formation would immediately break apart into individual aircraft or pairs to avoid being trapped by Allied escort fighters. At that point, survival depended on situational awareness, energy management, and disengagement tactics. If ammunition or fuel ran low, or if the aircraft was damaged, pilots were expected to break contact and return to base rather than press the attack. Combat in the Bf-109 G6 was fast, unforgiving, and brief. Success depended less on prolonged dogfights and more on positioning, timing, and decisive fire in a single pass. The Bf-109 G6 was powered by the Daimler-Benz DB605A1, a liquid-cooled, 12-cylinder inverted V-engine designed to deliver high performance at altitude. At sea level, the engine produced up to 1,475 horsepower when operating on emergency power. This allowed the aircraft to reach a maximum level speed of around 400 miles per hour and up to 466 miles per hour in a dive, although structural instability could occur beyond that limit. One of the DB605's greatest strengths was its exceptional climb performance. The Bf-109 G6 could climb at over 3,500 feet per minute, reaching operational altitudes quickly, a critical advantage in interceptor roles. To manage the heat generated by such power, the engine relied on an active liquid cooling system. 2 radiators mounted beneath the wing roots cooled a water glycol mixture circulating through the engine. Incoming airflow removed heat before the coolant returned to the cylinder blocks. The engine was equipped with an automatic supercharger, essential for maintaining power at high altitude. Air entered through an intake on the fuselage side, passed through a centrifugal impeller, and was compressed before feeding into the cylinders. During climbs or combat maneuvers, this system provided a noticeable boost in performance. Power was transmitted through a metal-bladed, constant-speed propeller, nearly 10 feet in diameter. An automatic pitch control system adjusted blade angle continuously, reducing pilot workload during combat. While powerful and responsive, the DB605 demanded careful management. Overheating, overboosting, or battle damage to the cooling system could quickly lead to engine failure, making engine discipline a constant concern for Bf-109 pilots. Throughout its service life, one of the Bf-109's most serious limitations was its short operational range. The primary fuel tank was an L-shaped, self-sealing rubber tank mounted behind the cockpit. It held just over 105 gallons of fuel, enough for roughly 90 minutes of flight under combat conditions. Fuel was delivered to the engine through a direct fuel injection system, supported by 2 high-pressure pumps. Unlike carbureted engines, this system allowed the DB605 to maintain fuel flow during negative G maneuvers, giving the Bf-109 a tactical advantage in dives and abrupt evasive actions. Despite this, internal fuel capacity severely limited endurance. On typical combat missions, the aircraft's effective range was only about 160 miles, forcing pilots to operate close to friendly airfields. To compensate, the Bf-109 G6 frequently carried an external drop tank mounted beneath the fuselage. This tank held approximately 79 gallons, extending the operational range to nearly 280 miles. Fuel from the external tank was transferred to the main tank using pressurized air. Inside the cockpit, the pilot monitored fuel flow through a transparent indicator tube. When air bubbles appeared, it signaled that the external tank was empty and could be jettisoned. The aircraft typically operated on 87-octane fuel, which was an important logistical advantage late in the war, as higher-octane aviation fuel became increasingly scarce. While the fuel system was efficient and reliable, the limited internal capacity remained a constant constraint, shaping mission planning and reinforcing the Bf-109's role as a short-range interceptor rather than a long-endurance fighter. The Bf-109's landing gear was one of the aircraft's most well-known weaknesses. The main landing gear was hydraulically operated and retracted outward from the fuselage into the wings. This narrow track reduced aerodynamic drag in flight, but made ground handling difficult and unforgiving. The tail wheel was fixed and non-retractable, simplifying construction but adding drag. Unlike some later fighters, the Bf-109 had no emergency hydraulic backup system for retracting the landing gear. In the event of hydraulic failure, the pilot could deploy the gear manually. A T-shaped handle on the right side of the cockpit released the locking pins, allowing the landing gear to fall under its own weight. To fully extend and lock the gear, pilots were instructed to rock the aircraft side to side, using gravity and motion to seat the mechanisms. This system worked, but it demanded calm handling and altitude, not always available in combat damage scenarios. The narrow landing gear caused frequent accidents, especially during takeoff and landing. Poor forward visibility, torque from the powerful engine, and uneven airfields often resulted in ground loops or wingtip strikes. It is estimated that around 10% of Bf-109 losses occurred during takeoff or landing, particularly among inexperienced pilots. Despite these drawbacks, the design had one major advantage. The aircraft could remain standing on its landing gear, even with the wings removed, allowing rapid field repairs, wing replacement, and easy transport by rail or road. In operational terms, the landing gear reflected the Bf-109's overall philosophy, optimized for performance in the air, even if it demanded compromises on the ground. The cockpit of the Bf-109 was notoriously tight and cramped, especially when compared to Allied fighters. This compact layout was a deliberate design choice. By keeping the cockpit small, Messerschmitt reduced frontal area and drag, while keeping all controls within immediate reach of the pilot. In flight, nearly every essential switch, lever, and wheel could be operated without changing posture. The windscreen was heavily framed and reinforced, providing protection but restricting forward visibility. The standard canopy consisted of 3 sections, with a movable center panel, While functional, it limited situational awareness compared to later bubble canopy designs. On the left side of the cockpit, the pilot had two large handwheels controlling the flaps and elevator trim, along with the throttle lever and primer pump. The throttle incorporated multiple functions, including propeller pitch adjustment, fuel selector control, tail wheel lock, and an emergency canopy release. On the right side, controls for the oxygen system, radio equipment, and radiator settings were located, along with the main electrical circuit breakers. Many radio components were mounted low on the cockpit floor, reducing clutter at eye level. The main instrument panel was simple but effective. It included airspeed, altitude, compass, artificial horizon, and engine monitoring gauges. Prominently mounted at the top was the Revi-16B gun sight, positioned directly in the pilot's line of sight. Ammunition counters were placed on the left side of the panel, allowing the pilot to track remaining rounds during combat. A low fuel warning light provided roughly 20 minutes of remaining flight time, a critical margin given the aircraft's limited range. Overall, the Bf-109 cockpit favored efficiency over comfort. It demanded discipline and familiarity, but in experienced hands, it allowed fast reactions and effective combat control, even under extreme stress. Starting the Bf-109 was a precise, step-by-step process that required close coordination between the pilot and ground crew. Before engine start, the canopy was closed to prevent airflow from damaging it. The battery was switched on, elevator trim set to +1, and the propeller pitch system activated. The pilot briefly set propeller pitch to manual to verify correct blade angle, then returned it to automatic control. Fuel valves were opened, and the throttle advanced slightly, typically to about 1/3. The coolant radiator was set to manual and fully open, ensuring maximum airflow during startup. Using the primer pump, the pilot injected fuel into the engine, usually 4 to 6 strokes depending on temperature. The electric fuel pump was then engaged to pressurize the fuel lines. Once the ground crew signaled readiness, the pilot switched the magnetos to M1+2. The starting handle was pulled sharply, and the engine ignited as the pilot continued priming briefly. As the DB605 caught, the throttle was reduced to stabilize idle speed. After confirming oil pressure and smooth engine operation, the electric fuel pump was switched off. The aircraft was now ready to taxi. The entire procedure was quick but unforgiving. A mistake in sequence or timing could flood the engine, damage components, or delay takeoff under combat conditions. Taxiing the Bf-109 was one of the most challenging phases of ground operation, especially for inexperienced pilots. The aircraft had extremely poor forward visibility due to its long nose and tail-low stance. From the cockpit, the pilot could not see directly ahead, making straight taxiing impossible. To compensate, pilots used continuous S-turns, weaving left and right to clear the path ahead. Directional control on the ground relied almost entirely on differential braking. The narrow track landing gear provided little inherent stability, and aggressive brake use could easily lead to ground loops or tip-overs. Engine power was kept low to avoid excessive torque and prop wash. In many cases, especially on crowded or uneven airfields, a ground mechanic sat on the wing or walked alongside the aircraft, signaling obstacles and guiding the pilot. Taxiing accidents were common, and a significant number of Bf-109 losses occurred before ever reaching the runway, highlighting how unforgiving the aircraft could be even outside combat. Taking off in the Bf-109 demanded precision and constant attention from the pilot. Before the takeoff roll, the canopy was locked, the tail wheel engaged, and the trim set to +1. Flaps were lowered to 20 degrees, the propeller set to automatic pitch, and the cooling system placed under automatic control. As engine power increased, the aircraft showed a strong tendency to yaw and swing, caused by engine torque, propeller slipstream, and the narrow landing gear. This required firm and immediate rudder correction, a task that often overwhelmed inexperienced pilots. At approximately 62 miles per hour, the tail lifted, improving forward visibility and rudder effectiveness. Liftoff occurred just above 105 miles per hour, after which the pilot briefly applied the brakes to stop wheel rotation before retracting the landing gear. Liftoff occurred just above 105 miles per hour. after which the pilot briefly applied the brakes to stop wheel rotation before retracting the landing gear. Many Bf-109 seconds were lost during takeoff due to loss of directional control. Despite its excellent performance in the air, the aircraft remained unforgiving on the ground, making takeoff one of the most dangerous phases of flight. The Messerschmitt Bf-109 remains the most produced single-seat fighter aircraft in history, with more than 34,000 units built. Throughout World War II, it fought in every major theater, from the frozen skies of the Arctic, across the deserts of North Africa, to the high-altitude battles over Germany itself. No other fighter was adapted to so many roles and environments for such a long period of time. The Bf-109 G6 entered service in early 1943, at a moment when Germany was already losing strategic initiative. Despite this, the Gustav remained a lethal and capable fighter, flown by many of the Luftwaffe's most successful aces, and, as the war turned, by many who would not survive it. Its design was a study in compromise, exceptional climb and performance in the air, paired with difficult ground handling and limited range. These strengths and weaknesses shaped both its victories and its losses. In total, Bf-109 pilots claimed around 30,000 aerial victories, making it the deadliest fighter aircraft in history by kill count. But its legacy is not only measured in numbers. The Bf-109 represents the limits of wartime engineering, a machine refined continuously under pressure, pushed beyond its original design, and flown until the very end of the conflict. It stands today as one of the most iconic aircraft ever built, and a symbol of how technology, doctrine, and human skill intersected in the air war of the Second World War.